Dear students, today we are going to do chapter 2 polynomials. This chapter has been divided into 6 parts. In part 1, we will be learning introduction of algebraic expression and also to identify polynomials. Part 2, we will be going through types of polynomial and we will learn how to find the value of polynomial along with zero of polynomial. In part 3, we will learn long division method and the remainder theorem. Part 4, we will be learning factor theorem and we will do examples from textbook. Part 5 will cover extra questions based on factor theorem. Part 6, we will learn algebraic identities. In that, we will be covering 10 identities with explanation. Let us understand what are algebraic expressions. A combination of constants and variable connected by the fundamental mathematical operator, that is plus, minus, multiplication or division sign, is known as algebraic expression. Let us understand it with example. 3x plus 10. Here we have got constant 3 and 10. We have got variable x. Here 3 and x are connected by multiplication and we have got a plus sign here. Hence it is an algebraic expression. Next example, 5x plus 3y plus 2. One more, 1 by x plus 3 is also an algebraic expression. Here we have got variable x, constant 3, 1 and x is connected by division sign and we have got a plus sign. 2m. This is also an algebraic expression. Let us now understand the basic terms used in an algebraic expression. The first one being terms. What is term? Each part of an algebraic expression which are separated by plus or minus sign is called the terms of an algebraic expression. Let us take the first example, x plus 10. Here we see there are two terms, x and 10, and they are separated by a plus sign. There are two terms and the terms are x and 10. Second example, 5m plus 2n minus 7. Here we have got three terms, 5m, 2n and minus 7. First two terms are separated by plus, second and third term is separated by minus. Hence the terms here are (5m), 2n and minus 7. Next, coefficient. The numerical factor of a term that contains a variable is known as coefficient. Suppose we take an algebraic expression x cube minus 3x square plus 4x plus 10. The coefficient of x square here is minus 3. What is the coefficient of x cube? The coefficient of x cube is 1. Let us take another example. 3x plus 5. Coefficient of x in this case is 3. Next we have to learn what is constant term. A term with no variable is known as constant term. If I take an algebraic expression 5p plus 4, here we have got two terms. The first term contains a variable p, but the second term does not contain a variable p. Therefore, 4 is the constant term. What is degree of a term? The degree of a term is the exponent of the variable that appear in it. If we have an algebraic expression 5x cube minus 2x square plus 10x minus 3. Here we have got 4 terms. The terms are 5x cube, minus 2x square, 10x and minus 3. Let us see what is the degree of each term. The degree is the exponent of the variable. What is the power of the variable here? 3. Therefore, degree is 3. Here, x is raised to 2. Therefore, the degree is 2. Here, it is x raised to 1. Therefore, 1. Now, regarding minus 3 can be written as minus 3 into 1, which can be written as minus 3 into x raised to 0. Therefore, degree of the non-zero constant term is 0. Let us take one more example. Two square x plus 5. Here there are 2 terms. The terms are 2 square x and 5. Let us see what are the degrees of the term. Now, the degree of the first term is not 2, because what is the definition? The degree of the term is the exponent of the variable. What is the exponent of the variable here? It is 1. So, degree is 1. And what is the degree of a non-zero constant? It is 0. All the algebraic expressions are not polynomial. Let us learn how to identify a polynomial. What is a polynomial? An algebraic expression in which the variables involved have only non-negative integral power is called a polynomial. Or in other words, the exponent of the variable should be a whole number. Let us understand it with example. Here the given algebraic expression has got 4 terms. The terms are minus x cube, 4x square, 7x and minus 2. Degree of the first term is 3. Degree of the next term is 2. Here the degree is 1. And as we already know, degree of a non-zero constant is 0. We can see all the degree here are whole number, hence the given expression is a polynomial. Let us take second example, 3y square plus 5y. Here we have got 2 terms. The terms are 3y square and 5y. What is the degree of the first term? It is 2. Degree of the second term is 1. 2 and 1 are whole number, therefore the given expression is a polynomial. Third example, x plus 1 by x. Here we have got 2 terms, that is x and 1 by x. What's the degree of x? It is 1. What's the degree of 1 by x? 1 by x can be rewritten as x raised to minus 1 using the law of exponent a raised to minus n is equal to 1 by a raised to n. Therefore, the degree of 1 by x is minus 1. As you can observe, minus 1 is not a whole number. Hence, the given expression is not a polynomial. Let us take the next example, 2u. Here there is only one term and the degree of the term is 1. 1 is a whole number. Therefore, the given expression is a polynomial. Let us take the last example, 2 root t plus 7. Once again we see it has got 2 terms, that is 2 root t and 7. What's the degree of 2 root t? Root t can be rewritten as t the whole raised to 1 by 2. Using the law of exponent, nth root of a is equal to a the whole raised to 1 by n. So the degree of the first term here is half. Half is not a whole number, hence the given expression is not a polynomial. Now let us understand what is degree of the polynomial. The highest power of the variable in a polynomial is known as degree of the polynomial. If we take an example, 2x square minus 3x raised to 5 plus 5x raised to 6. How many terms we have got? We have got here 3 terms. What are the degree of each term? Degree of the first term, as you can see, is 2. Degree of the second term is 5 and degree of the third term is 6. 6 is the highest power, hence 6 is the degree of the given polynomial. Let us take one more example. (16 plus 8x minus 12x square plus 15x cube minus x raised to 4. As you can observe, 4 is the highest power, hence 4 is the degree of the given polynomial. Let us understand the general form of a polynomial. Here, let x be a variable n be a positive integer and a0, a1, a2 up to an be constants. That is a0, a1, a2 up to an are any real numbers. Then an x raised to n plus an minus 1 x raised to n minus 1, it goes on till a1 x plus a0, where an is not equal to 0, is called a polynomial in variable x and degree n. Generally, we use the notations p of x, g of x, q of x, etc. to denote a polynomial in variable x. Hence, the general form of the polynomial can be denoted by p of x is equal to. Now, in the discussion, we have dealt with polynomials in one variable only. We can also have polynomials in more than one variable. Examples of it: x square plus y square plus 2xy. This is a polynomial in two variables. U square plus v cubed plus 3w. This is a polynomial in 3 variables.